In the last video, we were able to see that this function is actually c of x equals 40x. Now, let us recall that if the function, especially this expression, has this with the highest exponent as 1, although we don't write it, this is considered as a linear function. And now, how does it represent a real-life situation? Because knowing that the function c of x, let's just transfer it here, equals 40x, we can now have x as any number that we would like it to be. Why? Because if you remember, the domain of this would be the set of all real numbers. However, though, we can't have negative 2 meals. That is not actually real. So that would mean that we have to remember that even though mathematically this is the domain of it for the situation would be, it should be the set of all x such that x would be greater than or equal to 0. So let's label this. This is our actual domain. Actual domain. This is the domain according to the situation. Because we don't have negative number of meals. We can have half a meal, 1/2 meal, which is fine, which is part of our domain right here. And because already we know this function, we know this as the relationship between the number of meals and the price, which is 40 here. Therefore, we can easily identify how much would be if we would have 5 meals, 6 meals, 7 meals, even 100 meals, and so on. And that is basically how modeling works. That is why we study functions. Let's have this example now. 100 meters of fencing is available to enclose a rectangular area next to a river. This one here, this is our river, and 100 meters of fencing is available. Give a function a that can represent the area that can be enclosed in terms of x. So let's work with what we know. We have 100 meters of fencing. Oops, sorry. There you go, that's better. And this would mean that this line here, this line there, up until here, would be 100 meters of fencing. So that's the first thing that we would know. This rectangular area has one of the borders at the river. That's why we only would see this one here. 3 sides of our rectangle. We are asked now to give a function a that can represent the area that can be enclosed in terms of x. So we want to know this area, what can be the relationship of that area in terms of x, which is this specific length. Now, how will we now solve this? Pause the video and try to see if you'll be able to figure out the relationship. So, we know that if it's area and it's a rectangle, we usually have length times width, because that's the formula that we have learned before in our previous maths. However, though, our length is represented by x here, so we can have that as x, while the other width is represented as y, and that would be our area. However, we need to represent in terms of x. It doesn't say in terms of y as well. And as we all know, y is usually associated with this one, with our function notation, so we cannot use y. So how will we now represent this as x? Our answer would be on the first sentence. 100 meters of fencing is available to enclose a rectangular area. We know that if we're talking about fences, we are talking about the concept of perimeter. And the perimeter of a rectangle would be twice the length added to twice the width. However, if you would notice, one length is actually missing. This is actually not there. So instead of two lengths or twice lengths, we will just have the perimeter that of our area would just be one length plus twice the width, because this is the only length that we have, but we still have two widths here, which is our y. So if we will represent it instead of L and W as x and y, we'll have P is equal to x plus 2y. And what is our perimeter? It's this one, the 100 meters. So I will make this now 100 equals x plus 2y, because our perimeter, this P here, is actually 100. Now, since we want y to be expressed as x, therefore we can solve it using this expression now. So I will now have here 100 equals x plus 2y. I want y to be an expression in terms of x. I want y alone. So I will transpose x there. So I will have 100 minus x equals 2y. Divide both sides now by 2, and I will have y is equal to 100 minus x over 2. Or you can also have 50 minus x over 2. 100 divided by 2 is 50, and negative x over 2 is just x over 2. So now, we will be able now to express y in terms of x. So that means now our area would now be x multiplied to the value of our y here, which can be 50 minus x over 2. If this is what we will use, therefore, a as a function of x would be 50x minus, because that's times 50, would be minus x squared over 2. Or, let's just write it up here. We can also have a of x. Instead of using this one, we will use this one instead. We will have, so 100 x times 100 minus x over 2. And that will give us a of x would be equal to 100x minus x squared over 2. And this expression and this practically mean the same thing. Therefore, we already have a function a that can represent the area enclosed in terms of x. And as you can see, both of this have an x squared with it, this one here. Therefore, we can say that we have now a quadratic function.